everyone and welcome again to my channel The Deep AI Dive. So last time we discussed AI, ML, deep learning and as in how they are differentiated with each other. In this lecture we will talk about simply the neural networks, the basic foundation of neural networks. How does the neural network work? Why is it so powerful? And as seen in the discussion, we saw that it actually learns these things hierarchically. But how does it do it? So let's try to understand that. Okay, last time we understand a very basic thing, that a simply line is represented by a linear combination of variables. What does that mean? So theta naught, theta 1, x1. So this is a line in two-dimensional plane. So it's just like this is b, this is m, so it is mx plus b. But right now I'm changing the notations, right? Because these are the standard notations that people use. So this is a two-dimensional line. Similarly, we can have a three-dimensional line, which is also called as a plane, etc. and so on. Okay. So there are different ways to write this. Whenever in machine learning or deep learning in general, in linear algebra, whenever I write a vector theta, so it's always a column vector. So let's do one thing, right? Let's assemble all these thetas to one vector and make it as a column vector, like theta naught, theta 1, theta 2, dot dot theta n. Let's say there we have n dimensional column vector. Similarly, I make another vector x as another column vector which contains these x1s. Now I write something like this: 1 x1 x2 dot 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 xn. Now why I wrote 1 here, you will understand this in a while. Now let's do one thing. Let's do theta transpose x, the dot product. So theta transpose is simply transposing this column vector and it now becomes the row vector, something like this: theta naught, theta 1, theta n, and x is simply 1 x1 x2 dot 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 xn. Now if we do the dot product, it's simply like this. I mean, I guess you have already done this in a basic mathematics class. So when you do it, you will get the same result as above: theta naught into 1 theta naught, theta 1 into x1, that would be theta 1 x1 plus theta 2 x2 plus dot 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 theta n xn, exactly as the same result like this. Now why I gave you this short tutorial? It's because this function is the most important core function of neural network. This is actually the linear function, or I can also say linear combination of these variables, right? And this is nothing but a line in a very high dimensional plane. This you already know. Now what does neural network does? It does exactly the same thing, but with a small twist. Now let's understand this one neuron. As we saw in previous, just a while ago, we have several neurons and every neuron learns something basic. So if we have this one neuron, now if it takes some inputs and it does something and it gives some output, that's what we saw, right? So what exactly does it do? Let's see. Now we have x1 here, x2. So this is, let's say, input layer, and this is the first hidden layer, and let's just see this let's just see this neuron, just the first neuron of the hidden layer. Now this does some function f and it gives the output. Now what is this function? It's nothing but exactly this same linear function. So it's simply, so with every edge it associates a weight. Let's say here I did theta 1, theta 2, and the output is the same: theta 1 x1 plus theta 2 x2. That's what f does. Now where is theta naught? So in order to add a theta naught, at every layer we also add a third connection with 1. So also in the input layer there is also 1 on the top, but we didn't show it because it's hidden, but it's always there. So we associate theta naught in here. So now it becomes theta naught into 1, that means theta naught. So theta transpose x. So every neuron actually does the same thing. So this is the first neuron, right? So in hidden layer we had several other neurons. So this one will also go here, this x1 will also go here, this x2 will also go here, and here the weights would be a little bit different. It would be, let's say, theta 3 for this edge, it would be theta 4 for this edge, it would be theta 5, and this would also give the same thing, theta 3 plus theta 4 x1 plus theta 5 x2, some another theta p transpose x. Now you might be wondering, if everybody is doing a same linear job, how does this neural network learns a non-linearity, right? Because if you remember last time we saw that if we have some data set something like this, the neural network might also bend the line. But then if this is a linear function, this is also a linear function, this is also a linear function, the output is a linear function, it goes to another hidden layer, and those hidden layer also does the same thing. So it will also output a linear function. Then how does it become non-linear? If everything is linear, the output will also be linear, right? So that's what the twist here is, that after doing this computation, neural networks adds a non-linearity, and this non-linearity is actually to make the output non-linear, so that neural network can create such boundaries as well. Not just like this, it could be very complicated boundaries, something like this or this, depending on your requirement. Right now for this case we want this because we want to do classification, right? Now how does it add non-linearity? There are several non-linear functions for it, like you have heard of maybe ReLU function, softmax function, etc and etc. So let's first of all understand a simple what nonlinear function does by softmax, because it's the most easiest case. So softmax is a nonlinear function and it's given by 1 upon 1 plus e to the power negative x. Now, whoa, what is this and how does it come into the picture? Let's plot this. So if you plot it, it will come something like this. Something like this. So it goes something like this here. So here it goes towards 0 and here it goes towards 1. Now this is 0.5. Well, this is x. So if you see, if we put x is 0 in this function, then it would be 1 upon 1 plus e to the power 0, which is 1 by 2.5. So that's what it is. So it means that if you give x as positive value, if x is greater than 0, if you see that the function is actually approaching 1, right? And if x is negative, the function is approaching 0. So that basically means for theta transpose x, after getting the output from the first neuron, I apply this softmax represented by sigma of x. That means sigma of theta transpose x. So if this inner value is actually greater than equal to 0, then this would output a result greater than equal to 0, or let's say 1 for now, right? Similarly, if sigma theta transpose x, if this value is less than 0, it will give us an output less than 0, right? Or let's imagine for now as 0. Now if you see here, these theta transpose x will give you an output of linear line. Now on top of this linear line, we pass this to another non-linear function sigma. So as a result, this whole thing would become a non-linear function. That means or in simple terms, we if we pass a linear line in this non-linearity, now that line would start to bend because there is now non-linearity present in it. So that's how the neural network works. So let's understand again by a very simple example. So what it is doing, so if we have, let's say 2 4, and then this is first hidden layer, this is second hidden layer, right? Let's say 2, and third hidden layer as, let's say, just 1. So it goes here, right? And then this goes here, this goes here, something like this. So this also computes. So this, let's say if this is f, so this output here would be sigma of f. Again, this would be sigma of f1 because the function would be different. f2, sigma of f2, this would be f3, then sigma of f3, and then if this is f4, then sigma of f4. Right? Now how does this is f1, f2, f3, if everything is doing the same job, everyone is doing the same job, how is the output different? Because these weights would be different. These theta knots, this theta 1, this theta 2, this theta 4, theta 5, these are called as the parameters. And now, like for example, in this case it is theta naught, for this it could be theta 1, for this it is theta 2, for this it is theta 3. Even though the underlying function is linear combination, since these weights are different, the behavior of every neuron would be different. The behavior of every neuron would basically be different.